guys, my name is Rajan and today we're going to be solving this problem, partition equals subset sum. The problem is we are given a array which is a non-empty array and it only has positive integers, and we have to partition the array in such a way that um, the sum is equal to it's divided into two different equal sub-arrays. It doesn't have to be continuous. For example, say find an array in the partition into two such that the sum of elements in both subsets are equal. So we basically have to divide it into two equal arrays. For example, in this scenario, 155 equals to 11 and another 11 is so both of those sub-array sums to 11. That's how we have to partition it. So thinking about it, this kind of problem are really common in Leetcode and maybe asked in a lot of interview questions. So I think the companies that ask this are Facebook, Amazon, and Google. And let's go to the approach that I'm going to use to solve this problem. And that approach can be used in a lot of problems where like you could not think of straightforward what the solution would be. So you can apply that approach. So what I'm going to do before that, let's think of how we can solve this problem. So can we apply some tricks where we sort this array first and then find out if it could be solved? For example, let's say we have this array over here, right? So let's say we sort it. So 1, 5, 5, 11. So in this case, we can just go on adding it, and then we get the sum of whole array, and then we will go on adding it to see if some portion of that is equals to half of the sum. In this case, it would work, but will it work in the other cases also? I don't think it would, because let's think of a scenario where it would not work. So let's say 1, 2, 3, 4, 3, 7. There could be some scenario where you might have to take this array and this element, and then you might have to take this and this. 11, 12, 7, 8, 9, 10. So this is 9. Yeah. So there may be some problem where you might have to take this and this, and then this and this. In which case, just going on summing it from the very beginning to the end would not work. So the only way you can solve this problem is subdividing the problem. Subdividing in the sense, what you can do is you can find the sum of all the array and then start searching for from index 0 whether the sum exists, the half of the sum exists or not. Let's say the half of the sum is k. So you check this element. If it is less, you check in the remaining array whether k minus sum up to this element exists or not. So in the remaining array, you are checking for some element k from here, right? So you will again check in the remaining array whether k minus this element exists or not. So that way you can search and divide this problem into sub problems and search and then return the result. So let's start coding this solution. So I will start by finding the sum of the whole array. So okay, so now that I have the sum, so half would be right, but this is an integer division. So if the sum is odd, then since we just have the integers, we cannot have we cannot find the half of the sum we cannot divide the array into half because the integer division would be a floating point, and sum of integers cannot come to a floating point, right? So just avoiding that condition, we can say if half is not equals to sum minus half, because if that's the scenario, we cannot find the half, we know that, right? Now what we can do is just do a backtracking, write a backtracking solution where we just divide the problem into sub problems and solve. So let's say I'll call it find. So I'm sending the original array, and then I'm sending the sum that I'm trying to solve, and then I'm sending it the index from which I want to start the search, right? So all the main logics will be done in this function or method. So let's say this is the target that we're trying to search, and this is the index from which we're starting the search, right? So let's eliminate, let's not go on searching if we find a edge condition where like the search cannot satisfy from this point onwards, right? So if we start it's greater than the nums that length or greater than or equals to, then we know that we've already exceeded the limit of the array, so it's no longer possible. What else? T is less than equals to 0, then it's no longer possible. Now the positive scenario, right? If start is equals to t, then we've already found our solution, so we can true. What else? If start is less than t, in that case we have to less than 3 and find, and then we include the current element and then find the t minus current element's value in the remaining element, and then we know that the sum exists. So what we can do is t minus start, and then we start sorting from start plus 1. This condition is true, then true, because we are including the current element that we are at, and then the remaining array which starts from start plus 1, we are searching the value t minus nums start. So if this returns true, that means this sum exists in the remaining array, so this the condition is true. We can find, we were able to partition that into two different sub arrays where the sum is equal, right? Otherwise what we can do is, so this is if we include the current element. So another solution could be where we do not include it into the current element. So what we can do is find okay, so we are searching for t again, but we did not include the current element. We went to the next element and try to find the value, that sum, right? So I think this would return us the result. Oh, sorry, return. Yeah, this is correct solution, but now the problem is it would be over. I think it would give us an overflow issue because we're going again and again for each and every value of t minus nums start. If it's in every possible value of t, we are going to the remaining subtree, sub in the array, and then try to find the solution again and again, even if the value of t is repeating or the value of start is repeating. So, and we can prove that if we just submit it, I think it will run into a timeout issue because the complexity right now is 2 to the power n, as order of big O of 2 to the power n. and that's because we don't have any memoization in place. So what we can do is we can have a dp. We can create something like this where we say dp equals to new boolean. We're passing t and that, right? Half and non-start length. This would be enough. Okay, let's make it +1. And now what we're saying is if dp t, if this is the t, we have to make it +1. dpt and start is not equals to null, because by default when you create an array of object, all the values will be null. So we can simply return dp t start. And the reason I made it object boolean instead of the classical boolean is because this we can by default will be initialized to null, and if we create the array of this boolean, it would be false by default, and that would cost us a lot of computation. So yeah, return true. Otherwise what we can do here is, before returning true, we can just memorize it. dp t start equals to true. Otherwise we can just memorize here also dp t start equals to this, and this will still run. But now that we are doing memoization, it would avoid all those 2 to the power n computations, and it would just do it in order of n. And we can submit this, and then it is accepted. It's faster than 74% of the solutions. So I hope you guys learn this approach, because this approach can be used in a lot of problems where you divide the original problem into sub problems and then go on tackling that problems, and finally you can memorize the sub problem, the solution of the sub problem, and reduce the complexity, and you can apply this technique to solve so many problems in Leetcode. Thank you guys for watching. See you guys in the next video.